Greetings, everybody. We have
Hi.
Jessica with us. We have Jesse with us. My name is Jared, and today I will be happy to cover our lesson here on our decimals. So let me get my screen shared with y'all. And let me ask y'all a question. You're probably familiar with numbers, but have you ever heard of an incomplete number? It may sound like a confusing concept at first, but once you get the hang of it, it's not as bad as it seems. My name is Jared Homshak, and today I will be asking you guys we'll be introducing you guys to decimals and how they relate to integers. This lesson will be guided by my two wonderful panelists here, Jessica and Jesse. At the end of the lesson, though, two major concepts will stick out. First, you'll be introduced to what a decimal is, and secondly, you will learn how decimals relate with integers. So let's get those questions rolling, shall we?
Jared, I have a question.
Go for it.
What is a decimal number?
I'm glad you asked. A decimal number is primarily a number that is made up of integers and an incomplete integer that is part of the integer 1 in the ones place. So, anything else?
Yeah, I have a question. Can you identify the different parts of the decimal number?
Sure. Right now, first we start off here with digits. These are just the numbers telling us what is represented in the number itself, such as how we know that here in our picture example here that, where is it? Here we go. That 1 is the value in the tens place and 2 is the value in the tens place. And it's split up into two halves. We have our integers here. These are the whole numbers. And then to the right of and then we have our decimal point, which splits up the integers and the non-integers. And then our incomplete whole number, I guess you could put it, is here to the right. These will always split up into values such as tenths, hundreds, and thousands. The ultimate goal here is to have you guys realize that a decimal number is just simply representing a number that can't be represented by integers and can include this incomplete whole number that we have right here. This will be very important to learn. So I'm glad you asked that. Anything else?
I have a question. Can you explain what is happening when a decimal number is represented on a number line?
Sure. Matter of fact, I have a number line ready to go. So basically what's happening is this. So decimal numbers, it's just simply non-integers. So I've written out for us the number 3.5. So we know that 3.5, that's greater than 3 and less than 4. So as a result, we can mark here that 3.5 is located smack dab in the middle of 3 and 4. Likewise, negative 3.5, the same concept applies. It's going to be right here in between negative 3 and negative 4. See, the same process applies as if we were going to try and find 1 or 2 or negative 1 or negative 2 on the number line. We're just finding decimal numbers instead of integers. So we're looking in between the integers is how you can think of it. Good question. Anything else?
Yeah, so how would you show your understanding of decimal numbers while solving a problem?
Well, good question, Jesse. I can do that primarily by using decimals in math problems to show it. We're going to do it in two ways, through rounding and through operations. Allow me to demonstrate. So let's start off with rounding here. We have the number of 3.91. We want to know how it would be rounded to the nearest integer and to the nearest tenth. The main thing to remember when rounding is to look at my picture over here where it says rounding numbers. When the number is 5 or more, you want to round up or let it soar. You can think of it. Likewise, when it is less than 4 or 4, we need to lower that number down or let it rest. So with that in mind, let's work on our problem here. So 3.91. To the integer, we want to look to one place to the right to determine how we need to round. So that value here is 9. So 3.9, is it 5 or more? Very much so. Matter of fact, it's 3.9, which is about as high as you can go for that specific place value. So as a result, we know that we can round it to 4. So 3.91 is closest to the integer of 4. Now, with that in mind, I'd like you guys to practice on your own and try to identify how this number will be rounded to the nearest tenth. So let's look at operations now. It's just the same concept. The only difference here is that you're having to subtract values less than 1, or the non-integers. So let's start. 6.0, let's take our starting number, 6.05, and let's subtract 3 from it. 6.05 minus 3, you should be able to figure this one out pretty quickly. That would be equal to 3.05. So now that we know that, let's subtract a tenth from 3.05. That 3.05 minus a tenth, that will now equal us to 2.95. Please excuse my terrible handwriting. And finally, we just need to subtract 4 100ths from 2.95. So 2.95 minus 0.0.4 gives us our final answer of 2.91. So, as you can see, subtracting kind of works the same for both integers and decimals. You're working with values to the right of the one's value. So, great question, and if you can, work on this problem here, 8 minus 2.63 on your own, like we did with this problem up here. Any other questions?
I have one, Jared. How would you estimate the results of addition or subtraction problem that you use decimal numbers?
Well, you just round it. Good question. You just round it to the nearest integer because you want to get rid of the decimal, and then you work with the integers that you have to get an estimated answer. Allow me to demonstrate. So let's look at our number here. We have 8.72 minus 2.03. Well, let's start yet again. Well, first of all, let's round this up. 8.72, the one digit to the right of 8 is 7. 7 tenths, 8.7 tenths, you need to round that up because remember the rule of 5. 5, if it is 5 or higher, you're rounding up, so we will be rounding up to get 9. And then we are taking away 2.03. Well, 3 100ths. You're just rounding that down to 2. So 9 minus 2 is our problem. And from there, you take away 9 and 2 to get 7. 7 is not the final answer, though. That's only an estimated answer. That's the goal. If we were able to work out the problem in its actual form, we would get 8.72 minus 2 is 6.72. Minus 3 100ths gets us about 6.69, which, if rounded up, gives us 7 as an integer. So, as we can see, that estimation is correct. We have time for one more question.
Okay, so my last question is, based on what you know, how would you explain the importance of integers in mathematics in the real world?
Perfect. Well, it can be applied, like you said, in both math and in outside the classroom. In math, the most important thing to realize is that decimals are represented as fractions in the higher levels. Let me demonstrate. Up here in the graphic, we have 1/2, 1/3, and 1/4. That's just another way of saying that 1/2 is the same as 0.5 in a decimal. 1/3 is 0.3 repeating as a decimal, and 1/4 is 0.25 in the decimal form. It's important to recognize this because these two terms and concepts are used interchangeably, especially in the higher levels with things like college algebra. So you need to realize that, make this connection as soon as possible, and it will make your math life a whole lot easier. Outside of the classroom, well, The most important thing that decimals do is that they can give you a much more accurate read of something. Like, for example, 250 and a half is much more accurate than 250 or 251. And with that in mind, can really help you understand something, such as when you're grocery shopping, the exact weight. You want to know the exact weight because it will determine how much it costs. And with a budget, you don't want to overspend if you don't have to. And it also works for weight loss because if you lose that half a pound, it tells you if you need to lose a pound, like say if it's 250 and a half your weight, knowing that you need to only lose a half a pound is different from knowing you need to lose a pound and can help you get an even better read on how you're doing. So with all that being said, that concludes our lesson here on integers and decimals. To recap, we started off by introducing the concept of the decimal point and what it's designed to represent. Once we introduced that, we were able to perform operations with them and relate them to integers. I really hope this helps clarify any questions that y'all have. Now, if it doesn't, you're still confused, stick around because my friend Jessica is going to give an even more in-depth explanation of what decimal is. Jessica, the floor is yours.
Thank you, Jared.
You're welcome.
Now I'm just going to give a small warning up front. Our panel, we're going to try something different. I'm actually going to give Jared control of my computer at some point during my presentation. So please bear with us as we try this experiment out. And Jared.
Yes?
Why should you never argue with a decimal?
I don't know. Why not?
Because they always have a point. Mathematicians, my name is Jessica Johnson, and I want to teach you about rounding decimals, ordering decimals, and adding decimals. I want to show you this neat little poem that I found about rounding decimals, and this can help you remember the 5-up rule. Underline the digit, look next door. If it's 5 or greater, add 1 more. If it's less than 5, leave it for sure. Everything after is 0, not more. Look at the decimal 4.125 and use the poem to round to the nearest integer. Underline the 4, then look next door at the 10th place, which is a 1. Since the 1 is less than 5, I will leave the integer the same. And we get the answer of 4. I need someone to round 4.125 to the nearest 10th place using the poem.
Oh, pick me.
Jared.
Underline the 1 in the 10th place. Look next door at the 100th place. 2 is less than 5, so leave it for sure, and we'll get the final answer. Ends up being 4.1.
Good job, Jared. Can someone round 4.125 to the nearest 100th place using the poem?
Yes, I got this. Okay, so you're going to underline the 2 in the 100th place, and then you're going to look next door at the 1000th place. And then since it is a 5, we add 1 more and we get the answer 4.13.
Thank you, Jessie. Great. Now last one. I need someone to round 4.125 to the nearest 1,000.
I got that one too. So I'll take, you're going to underline the 5 in the 1000th place, and then you're going to look next door. And there's a hidden 0 there. So based on the poem, 0 is less than 5, and so we leave it for sure. And then we get the answer of 4.125.
Great job, guys. Thank you. Now then, let's look at ordering decimals. Let's order the decimals 4.4, 2.8, and 3.1 from least to greatest. A little trick you can use to order decimals is you can stack them, so you can better understand the value of the decimals. Like this. For our decimals, they all have the same value. What do you think we need to do to start ordering our decimals?
Ooh, we need to look at the highest place value in the ones place left of the decimal and then compare from the lowest value to the highest value, or least to greatest.
You're right, Jared. So we're going to look at the 4, the 2, and the 3. Jared, I'm going to give you control of my computer now, and I'll order you to order these decimals from least to greatest on the number line, please.
Shall do. We start off with 4.4. That's almost halfway in between 4 and 5. So as a result, I'm going to place that here on the line, going to lean a little towards 4, and there you go. That's about a good accurate read for 4.4. Now 3.1 is very close to 3. It's greater than 3 and less than 4, almost 3. So as a result, I will reflect that. If I can get this thing to move. Yeah, here we go. I'm going to put 3.1 about where 3 is, but not quite, because it's not 3. Last, we have 2.8. That's going to be here between 2 and 3. And it's almost at 3, kind of like 3.1 is. So I'm going to apply the same logic here. Going to place it right about here. Leave a little room, though, because it is farther away from 3 than 3.1. And there you have it.
Thank you, Jared. I appreciate it.
You're welcome.
Now then, I would like to take a look at adding decimals. When adding decimals, you stack the decimals so that the decimal points line up. Then you're going to add as usual. When you're finished adding, bring down your decimal and you'll have your answer. Let me show you something. What if we don't line up the decimals? Do you see anything wrong with this?
Yeah, I do. If you don't line up the decimals, you'll be adding the hundredths place and the tenths place, and then you're going to get the wrong answer.
Jesse, you're correct. We do not want to add decimals like this. Let's line up the decimals and see what we get.
Okay, so with the decimals lined up with the correct place value, we will add it like normal, and then you're going to get the correct answer, which is 6.72.
That's right. This is how we add decimals. I hope that you enjoyed my presentation about rounding decimals, ordering decimals, and adding decimals. Now, I would like to turn the presentation over to Jesse.
Okay, give me just a sec. Get my PowerPoint pulled up. All right, so we are going to be talking about multiplying and dividing decimals. If my PowerPoint would start. It's loading. There we go. Okay, so multiplying and dividing decimals. So this isn't that hard. It's just as easy as adding them and subtracting them, like Jessica had showed us. So look at this vocab. So the decimal is actually relating to or donating a system of numbers and arithmetic based on the number 10, tenths parts, and powers of 10, which is actually just the tiny little dot mixed with all the numbers. That was my definition. Multiplying is obtaining from a number another that contains the first number or specified number of times. So 2 times 6, an example of multiplying. Dividing is you find out how many times a number contains another, so 6 divided by 2. And then their place value is the numerical value that a digit has by virtue of its position in a number. I thought those were really fancy definitions, so I wanted to share them with you. Okay, so multiplying decimals. I'm going to go ahead and get my drawing thing out. Okay, so we're going to look at this example. We're going to do 8.5. Oh, I'm sorry, not 8.5. We're going to do 4.3. Why is it not working? No. Oh, no. Okay, my computer froze. I'm so sorry about that, guys. Okay, so 4.3 times 3.7. So the first thing when you multiply is we're going to try to get rid of these decimals because they make the problem really, really confusing. So we're just going to kind of ignore them. And I don't know why my computer's glitching out right now. So we're going to rewrite it like this. 43 times 37. So it looks a little bit normal, and it's not as complicated as using the decimals. Those are kind of tricky. So we're going to do 3 times 7 is the first thing we want to do. And then we're going to get 21. So we'll bring our 2 over here. We'll put the 1 here. And then 4 times 7, and which is 30. Or, yeah, so we got 30 plus the 2, which is 301. And so then we're going to carry down our 0 because now we want to use our 3. So 3 times 3 is 9. And then we're going to do our 4 times 3, which is 12. And I know this looks a little sloppy. My computer's being really weird. Okay, so this is just like a normal multiplication problem. So far, multiplying decimals is kind of just the same. So when we add it all up, we get this. We get 1,591. So this is when our decimals start coming into place. So what we do is you're going to look at how many spaces are to the right of the decimal in each one. So on 4.3, it's just 1 space to the right of the decimal. And the same thing with 3.7. It's just 1. So we have 1 plus 1, which equals 2. And so that is how many spaces you're going to move your decimal to the left of the answer you got, which is this right here. So we're going to move our decimal 1, 2. So your real answer is going to be 15.91. That makes sense so far? Okay.
Casey,
go for it.
I have a question, if you don't mind me asking.
Yeah, no problem.
Can you multiply decimal numbers whose decimals are in different place values?
Yes, you can. So like I just had mentioned earlier with the, when you add your decimals with these underlined right here, when you add the places, that's the reason that you add those, is because you can add numbers that have different decimal places. So if I had 4.325, I could still multiply that to 3.7. I'm not going to do that example right now just because of time, but anyways, you can do that. So thank you, Jared.
You're welcome.
All right, so now we are going to move on to dividing decimals. So this is just as simple as multiplying decimals. We're going to do 4.3. I'm sorry, got this. That's the same example I just did. We're doing 8.5 divided by 3.4. Okay, so again, just like we had done with our multiplying, we're going to rewrite it because this isn't going to help us get our answers. So we're going to rewrite it by using long division. So what you want to do is you want to take your second number is going to go on the outside of long division. And then your first number goes on the inside. Makes sense so far? And so then what you want to do is the same thing that we did with multiplication, is you're going to move that little decimal over because it's hard to divide 3.4 and 8.5 with that little decimal. It just makes it confusing. So what you're going to do is you're going to move it to the right. So then you get what you really get is 34 and 85. And so then we're going to do our division. So how many times will 34 go into 85? So it'll go into it twice, which is 68. And then we're going to subtract. So once you subtract that, you're going to get 17. And so this is where it gets a little funny. So 34 cannot go into 17. So we need to add our zeros. In dividing decimals, once you get to the point where you need to add a zero, that is when we're bringing our decimals back into the problem. So we're going to put 2 here. We're going to put a decimal after that 2 and a decimal after that 17. And then we can bring down our zeros. So we have 17.0. So then we are going to do, how many times will 34 go into 170? And the answer is 5. It'll go into an even amount, which is 170. And so then you are done. There's no remainder because it goes into even. So then again, we have 2.5. And that is how you do dividing decimals. So that is actually all I had. Does anybody have any more questions, or are we all good?
I just have a comment. I think you did a great job explaining your division and multiplication. Good job.
Yes,
Thank
did
you. I know my
wonderful.
computer was being really glitchy, so I'm so sorry. I don't know what was going on.
It's okay. I appreciate the work and taking the time. It's better to take the time and ensure they get it. So you did
Thanks,
wonderful.
guys. Thanks. So anyways, guys, that was group 2. Thank you for bearing with us as we tried different things and we did our panel. So thank y'all so much. And this is going to be the conclusion for group 2.
Thank you.
Take care, everybody.